This question asks which of the following statements regarding ketones and aldehydes is false. Okay, so I'm going to get the pen out so we can work our way through. So the first statement says, in general, aldehydes are more electrophilic than ketones. And that's a true statement because the aldehyde has a hydrogen instead of kind of two R groups on either side. Sterically, it's typically a better electrophile. Statement number 2, both ketones and aldehydes can be formed from the ozonolysis of alkenes. Okay, that is also a true statement. We could take an alkene that looks like this, and if we undergo ozonolysis, it would make one aldehyde and one ketone. Okay, so statement number 2, also true. Statement 3, we can increase the electrophilicity of both aldehydes and ketones by adding an acid. This is also a true statement. Say you have an aldehyde or a ketone, and we add acid. We are going to add that to the oxygen of the carbonyl. And this makes an electrophile that's better than the original aldehyde because we have a resonance contributor where there is a full positive charge present right there. And so that makes it a stronger electrophile than the original where there was only a partial positive charge. Okay, let's take a look at statement number 4. To do that, I'm going to clear the screen off so that I have more space. So statement number 4, the oxidation of a primary alcohol with PCC yields only a ketone. So right away, I know that's false. Whenever we take a primary alcohol and we oxidize it with PCC, the key product here is an aldehyde, where we are converting the primary carbon attached to the oxygen into a carbonyl-containing molecule. PCC was a molecule that we use specifically because it allows us to stop at the aldehyde and we don't further oxidize to a carboxylic acid. Okay, the second half of this says, while the oxidation of a secondary alcohol with PCC produces both an aldehyde and a ketone. That second half of the statement is also false. When you oxidize secondary alcohols with PCC, you make only ketone products. So 4 is the only false statement out of all of the options we looked at. So the answer here is B, 4 only.